Assalamualaikum and hi everyone. Today I would like to share with all of you about one of the subtopic that have in statistical method and advanced application subject, which is spearman rank correlation coefficient. Spearman rank correlation coefficient is divided by two small sample and large sample approximation. First, we look to the small sample. Spearman rank correlation coefficient contain as it maintain that we must know and understand. Firstly, learning outcome. Students should be able to make a relationship between two variables by using Spearman rank correlation coefficient. Next, we go to assumption. The data consists of a random sample of n pairs of numeric and non-numeric observation. Second, each pair of observation represents two measurements taken on the same object or individual, called the unit of association. Then, the procedures of small sample. If the data consists of observation from a wide population, we designed the n pairs of observation S1, Y1, S2, Y2, and Sn, Yn. Second, each x is ranked relative to all other observed value of x from the smallest to largest in order of magnitude. The rank of the I value of x is denoted by rank Si equal to 1 if Si is the smallest observed value of x, is same with each y. Fourth, if ties occur among the x or among the y's, each tied value is assigned the mean of the rank position for which it is tied. Fifth, if the data consists of numeric observation, they must be capable of being ranked as described. Okay, let's move to the hypothesis of small sample Spearman rank correlation coefficient. For case A, which is two sides, x and y are independent for h naught, x and y are either directly or inversely related for h1. For case B, one-sided, h naught, x and y are independent which rho is equal to 0. For h1, there is a direct relationship between x and y, which is rho equal less than 0. For case C, h1, x and y are independent, which is rho s equal to 0, and there is an inverse relationship between x and y, which h1, there is rho less than 0. Okay, after we understand how to make hypothesis for small sample, we proceed to the test statistic. The first, we rank all sample observation from smallest to largest and find di and di square, where di equal to rank Si in different rank Syi. And third, sum of the square different in the rank observation from population Si and Y, which is summation of di squared. And for the fourth, the test statistic is Rs equal to 1 minus 6 summation of di squared over n squared negative minus 1. Fifth, Rs is to measure the strength of the relationship between the sample x and y values, and S an estimate of the strength of the relationship between x and y in the sample population. Sixth, when the rank of x is the same of the rank of y, for every pair of observation, we call perfect direct relationship. There is di equal to 0 and Rs equal to positive 1. Kinder also shown that in general Rs equal to negative 1 when the rank of one variable within each pair of observation SR or YY is the reverse of the other perfect inverse relationship. Rs equal to 1, Ry equal to n, Rs equal to 2, Ry is equal to n minus 1, and Rs equal to n, Ry equal to 1. For n pairs of observation, Rs equal to -1. This is a simple example which suppose in the table below that Si 0, 8, 2, 5, yi 10, 3, 9, 6. We rank X and Y. For rank Si 1, 4, 2, 3. For rank yi 4, 1, 3, 2. So we find the di squared equal to 20, then Rs equal to -1. And the last, Kinder also show that Rs can never be greater than +1 or less than -1. Then the final step in small sample is how to make the rule of spearman rank correlation coefficient. For case A, two-sided, Rs greater than R alpha over 2 or Rs less than -R alpha over 2. For case B, one-sided positive, Rs greater than R alpha. For case C, one-sided negative, Rs less than -R alpha. Okay, to make all of you more understand how small sample spearman rank correlation coefficient, we proceed to the example. This is the example, which is variation in blood pressure. They found that a doctor who read high on the systolic tended to read high on diastolic. Table 9.1 show mean systolic and diastolic blood pressure reading by 14 doctors. We wish to compute a measure of the strength of the relationship between the two variables, under the assumption that these 14 doctors constitute a random sample from a population of doctors. We wish to know whether we may conclude from the data that there is direct relationship between systolic and diastolic reading. Suppose we let alpha equal to 0.05. This is the table. And for hypothesis, H0, systolic and diastolic blood pressure reading by doctors are independent. H1, there is direct relationship between systolic and diastolic blood pressure readings by doctor, which is the claim. Test statistic, it is first column SI, YI, rank of SI, rank of YI. It is different rank SI and rank of YI. And we can find di squared, and summation of the di squared we can get 132.5 by formula Rs given, and we substitute the values and we can get 0.7088. For the critical value, we can get from table A.21, we for n equal to 14 and alpha 0.05, and we can get the 0.464. It's in the table A.1. We can get this. For decision, 0.7088 less than, greater than 0.464. We can reject H now, and the conclusion is there is enough evidence to support the claim that the doctor who read high on systolic tend to write high on diastolic blood pressure. Okay, here also we have the exercise that you can try to do it by your own, and the answer of the exercise you can get from the blog. It is exercise 1, exercise 2, and exercise 3. Later, I will show the link of the blog. Secondly, we look for last sample. For last sample, when the sample size is greater than 100, we cannot use table A.21, and compute that z equal to rs square root of n minus 1. This is the link block that I said that before. For other information, you can visit this blog. And that's all for me. Sorry if I make any mistake about this video. Thanks for watching.